Hi everybody, this is your last quiz review video for the semester for our quiz that we have this coming Thursday. So I'm really hoping that you will make sure that you not only are going through the motions on writing these questions down, solving them, practicing, making sure you understand, but really making sure if there's any questions at all about the content that is on this video that you come and talk to me during lunch, that you talk to me during office hours, so that we can make sure that I get your questions answered before the quiz, which is Thursday, because this is a big one for making sure that your grade is solid at the end of the semester. Please also remember that Friday of this week is, I'm going to collect all your notebooks for a notebook check. So it's a double whammy week where we have a quiz score coming in and the notebook check score coming in. And then the last thing I want to say before I get started is just a reminder that the 13th, Friday the 13th, Lucky Friday, is the last day to turn in any late work before the end of the semester, because I've got next week to work on those grades and make sure my report cards are all finished. So I need to have all that data turned in and done on the by Friday the 13th. That's everything. That's why I'm collecting your notebooks. That's why we've got our last quiz right here. There's lots of different things that are all coming together so I can get those grades done. So check Aries, see what's missing, make sure that you have everything turned in by Friday the 13th. I don't want to make any mistakes on there, so please double check my work by making sure that you look at Aries, make sure there's nothing there that's showing is missing that you have actually turned in. So double check it. As far as I know, I think we're all up to date, but that's your job also to make sure that you are on top of all of it. All right. So our quiz for Thursday is all four operations for mixed numbers, adding, subtracting, multiplying, dividing, with mixed numbers, and showing me all those steps so I can have some information about how I can give you as many points as possible. So don't skip any steps. Don't forget to do things. Well, we'll see when we practice. I'll show you. I am bound and determined not to make any errors during my video, so shame on me if there's any mistakes that pop in. I think we're going to be good this time. All right, let's get started. So get your notebooks out. We have 4 problems that we worked on in class today being Monday. I just changed one of the mixed numbers in each of the 4 problems so that it's a little bit familiar. Already, you're showing me all your thinking. You're going to do all that work. Take a photo of the work that you do today on these 4 problems and post it in Google Classroom. That's your evidence that you watched this video. Let's get started. So the first problem we have is 7 3/5. Here's our new number. I changed the second mixed number for our adding problem, 2 3/7. Can you please pause the video, solve the problem, and then start the video again to check and make sure that you didn't forget any steps. All right. Please remember that how I model it for you for all 4 of these problems is how I'm expecting it to look on the quiz. So don't skip any of my steps. Thank you. Get started. Pause and solve. Great. Let's get going. Ooh, what color should I pick? I'm gonna use black. It's actually kind of grayish. It's a little bit lighter. That's okay. All right. So as you remember, we cannot add fractions if the denominators are different. So our first step is going to be to find that common denominator. When you look at multiples of 5 and multiples of 7, the smallest number, the least common denominator that they share is 35. So I'm going to rewrite this to have 7, the whole number 7. We're going to have 35 in my denominator, 2 with 35 in my denominator. What did I do to my 5 to make it 35? I multiplied it times 7. If I multiply the bottom by 7, I have to multiply the top by 7, which gives me 21. If I what do I multiply times 7 is 5 to get 35. If I multiply the bottom by 5, I have to multiply the top by 5. These are my giant ones, you guys. right? The giant one that has something's cut into 5 pieces and we have all 5 of them. Any number times 1, that's the identity property of multiplication. Anything times 1 gives you that same number. So 2 3/7 times 1 is going to give me something that's the equivalent to 2 3/7, which is 2 15 35ths, right? So make sure we have changed our numerator and found our common denominator. All right, so now we have 7 21 35ths. We have 2 15 35ths. Now that the denominators are the same, we add across the top. Start with our whole number, actually. 7 plus 2 is going to give me 9. And I'm using that a little bit larger font size on the 9. For our fractions, 21 plus 15. 21 plus 10 is 31, plus 5 is 36. My denominator stays the same. Ooh, look at that. Isn't that friendly? 9 36 35ths. You'll notice it's improper because the numerator is larger. So down here or off to the side, somewhere where it's easy to see, let's just remind ourselves that 35 35ths equals 1 whole. So that this is going to equal 10 and 1 35th, because 35 35ths is 1 whole, but this is 36, so I have 1 left over. So I don't know why I made that 0 smaller. There we go. Now it looks kind of funky. Okay, close enough. So 9 36 35ths is the same thing as 10 and 1 35th. All right, I hope you got that answer. I double checked it. That is the correct answer. So in the quiz, I'd want to see you showing me what's your giant 1 here. I'd want to see how you rewrote those fractions. I want to see how you added. I want to see what you did to simplify this improper answer. If it happens to be improper, when you add, if it's not improper, then you're good. But just make sure that your answer is simplified if possible. All right. All right, good work. Let's move on to our subtraction problem. Our subtraction problem, 6 1/3 taking away 2 5/7. Please pause the video, solve it, and then meet me back here and let's go over it. Good work. All right. So 6 1/3, 2 5/7. Again, for subtraction, just like for adding, we can't do anything if the denominators are different. So when you look at those denominators, the lowest common multiple, counting by 3s and counting by 7s, the smallest number they have in common is going to be 21. So it's going to be 6 and some number in the numerator with the 21 in the denominator, 2 and something 21st. What do I multiply 3 by to get 21? That was times 7. If I multiply the bottom by 7, I have to multiply the top by 7. So I get 7. 1 times 7. 7 times 5 gives me, that is not true. 7 times 3 gives me 21. The bottom by 3, I have to multiply the top by 3, and I get 15. That was a close call. I saw that 5, and that was what spoke to me. So let me make sure I got it. 7 times 3, 7 times 3 times 7, 1 times 7, 7 times 3, 5 times 3. We are good to go. All right. Now I can subtract 6 and 2, but wait a minute. Here in my numerator, I have 7 21st, and I'm trying to take away 15 21st. I cannot do that. I don't have enough in my numerator here to subtract this. So I have to regroup. I have to do a little bit of borrowing. So in order for me to get more in my numerator here, I have to take away from here. Now I don't have 6, but I have 5. And this 1 whole is equal to 21 over 21, right? Something's cut into 21 pieces. I have all 21 of them. That's equivalent to 1 whole. I'm going to give that 21 to what I have here. Now I have a total of 28, right? So 5 and 28 21sts is the same thing as 6 and 7 21sts. Same value of this mixed number. But now I've got enough in my numerator to be able to do the subtraction problem. All right? So don't forget that you can take 1 away from your whole number, give the 21 here. All right? So now I can subtract. 5 take away 2 is 3. 28 take away 15 is 13. 21 is in the denominator. It stays in the denominator. So I ended with the fraction 3 and 13 21sts. Is that something that can simplify? Well, I hope when you look at that 13 that you start thinking, well, that's prime. And the only factors for 13 is 1 and 13. And 13 doesn't go into 21. 1 does, but that wouldn't change anything. Dividing both the numerator and the denominator by 1 won't help. So we are done. The answer is 3 and 13 21sts. Sometimes you end up with a fraction that can't simplify. All right. I hope that you got the same answer. Please remember that in your quiz, I'm going to want to see the evidence here of you rewriting these fractions. I want to see the evidence here of you regrouping so that you can subtract. I think there's a very good chance that on the quiz, you'll have to do that maneuver in that subtraction problem. If you have any questions about that, if you're not sure exactly how that works, come talk to me. Let's go over a couple examples of it. I liked this over here as my evidence about what happened in here. So I'm really kind of hoping that that can show up when you're doing your quiz. Just something that's neatly there so that I can see. And by the way, notice how I'm writing it's pretty big writing because I'm using a marker on a whiteboard. But some of you are writing really, really small on your papers, and it's easy for this to get kind of messy and confusing. So use a nice sized piece of writing when you're doing your work. All right. Multiplication problem. Here we go. 6 3/4 times 1 5/9. Please pause the video and solve it. And I'll meet you right back here to go over it together. Great work. Let's go over it and see how we did. Please remember that for adding and subtracting fractions, you have to have a common denominator in order to be able to add or subtract. Not so for multiplication or for division. Spoilers. You don't need to have a common denominator, but you can't work with multiplication and division with these fractions being mixed numbers. You have to turn them into just fractions where there's a numerator and a denominator. So we have to make them improper before we can actually work with them. All right, so let's do that. Let's start by doing this little conversion here where the denominator times the whole number plus the numerator goes into the numerator of that equivalent fraction. So 4 times 6 is 24, plus 3 is 27. My denominator stays the same. All right. Same thing over here. We're going to multiply the denominator times the whole number, add the numerator. 9 times 1 is 9, plus 5 is 14. My denominator stays the same. All right. So 6 3/4, that's equivalent to 27/4. 1 5/9, that's equivalent to 14/9. All right. So now these two still say the same thing. These are the same equivalent fraction problems, but now we can do the work that we have to do for multiplication of fractions, which is multiply across the top, multiply across the bottom. However, I hope that you are looking at this and thinking, oh, but I could simplify those fractions, pre-simplify or cross-simplify before I multiply them so that it makes them a lot friendlier to work on. So when I'm looking vertically, is there anything I can do? I have 27 and 4. I can't think of any common factors except for 1. 14 and 9, I don't think of any common factors except for 1. So it has to be something that's diagonal if there's something at all. Turns out there is. 14 and 4 both can be divided by 2. They have a common factor of 2. So I'm going to divide by 2. I'm going to divide by 2. This is my evidence of what you're doing when you're cross-simplifying, you guys. Don't forget to show me that. Now I have a 7 and a 2. I can cross-simplify this way. 9 and 27 have 9 as a common factor. All right? So I'm going to divide by 9, divide by 9. Now I have a 1 and a 3. Now, if you looked at 27 and 9 and thought, oh, they both have 3 as a common factor, and you do that, you would be right. They do. And that would simplify them. It just wouldn't simplify them all the way. It would make them simpler, but not completely simplified. If you left it like that and you multiplied, then you'd have an answer that you'd need to simplify again. But when you cross-simplify all the way, theoretically, you're going to then end up with the most simplified answer possible. All right? So I have a 3 and a 2. I have a 7 and a 1. I have a 7 and a 2. I have a 3 and a 1. I can't see of anything that I can do that is going to simplify these fractions any more than I currently have. So now I multiply across the top. 3 times 7 is 21. And multiply across the bottom. 2 times 1 is 2. Now it is improper, so I do have to simplify it to get it back into a mixed number. You cannot leave it top heavy like that. All right? But that's a pretty friendly conversion, right? Remember that this fraction bar here means divided by, so you would do 21 divided by 2. Well, we know that that's 10. There's the remainder of 1 that goes in the numerator, and the denominator stays the same. So this turns into 10 with 1/2 left over. 21, 2 goes into 21 10 times with 1/2 left over. All right? That's a really beautiful problem. If I didn't do this problem here in this sample, I kind of wish I could have used this one on the quiz. I really like it a lot. Ooh, because I like that I can convert it, and you just get, look at that, the 10 and a half is such a friendly answer. Really nice. Nice job. I hope that that is what you got when you solved your problem. We have one more. Let me do a little switcheroo of our boards here to make sure we are ready to go. We've got a division problem to do. 5.5 divided by 6 2/7. Now, you might look at that and go, well, that's kind of weird because the 5.5 is larger than 6 2/7, but you can do that. You can divide a larger number by a smaller number by a larger number, okay? I can have 2 cookies and divide it into 6 portions, right? So you can do division that way. Doesn't work that way for subtraction, but you can do it for division, all right? So, pause the video. I'll meet you back here. Let's go over it. All right. So, same deal. You don't need a common denominator. You didn't need one for multiplication. You don't need one for division. But you do need to turn them into improper fractions. You can't leave them as they are. They can't function the way that they do. Same way to turn them improper as you did before. The denominator times the whole number plus the numerator. All right? What? Why did I write? I don't know why I wrote that. It's a plus symbol. I wrote a little 2. I don't understand what I was doing there. All right. 2 times 5 is 10 plus 1 is 11. The denominator says 2. It stays the same. Divided by, don't skip any steps. No, 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 no. 7 times 6 is 42 plus 2 is 44 over 7. I'm keeping it division right now because right now this part of the problem is just turning it into improper fractions. Do not skip steps. Some of you today during our classroom practice were wanting to skip all kinds of steps, and I don't want you to show me anything that you demonstrating that you can skip a bunch of steps does not make me go, ooh, you're smarter than the rest. It makes me go, oh, you're not following my directions, which is show me every step. All right, so now I'm gonna invert the second fraction. I'm gonna find the reciprocal for the second fraction. The first one stays the same, 11 halves. Once I flip it, so now it's 7 over 44. Now it's a multiplication problem. All right, so I flip the second fraction. Now it's 7/44. It's multiplication. Now I can cross simplify. I can't cross simplify here. I can't cross simplify here. I have to do it only in the step when I've turned it into a multiplication problem. And look at that. There is lots of cross simplifying that we can do. Well, just one big one. Again, here, nothing, 11 and 2, no common factors except for 1. 7 and 44, no common factors except for 1. But diagonally here, 11 and 44 share a factor of 11. So divide by 11, divided by 11. Now I have a 1 and a 4. 7 and 2, no common factors but 1. 1 and 2, 7 and 4. That's as simplified as it's going to be. So let's get to multiplying. 1 times 7 is 7. 2 times 4 is 8. What a pretty little problem. It's very friendly, this one. A lot more friendly than the one I had in class today. Oh boy. But yeah, there you go. There's our 4 operations: adding, subtracting, multiplying, dividing. Just got to remember, adding and subtracting, common denominator required. Multiplication and division, fractions, improper fractions required. Right? No common denominator required. Once it's multiplication, it's just across the bottom, across the top. Right? So we're good to go. Those are our 4 problems. So please remember, where did I put that? Hold on a second. Please remember that earlier in class, last week on Friday, we worked in class on this sheet of word problems, and I said one of them was going to appear on the quiz. So don't forget to look through that. It's posted in Google Classroom. It was already in there for last week. So, but look through those problems and see if you can figure out, try and profile me and figure out which one of those ones is Mr. Dog gonna pick. I'll tell you, let's see, do I want to give you a hint? I kind of want to give you a hint. It's in the first 6 questions, 1 through 6, somewhere in there. It's one of those. So if you solve those 6 problems, then you will have already done one of the questions that is on this quiz. All right. Hey, thanks for hanging in there with me today, you guys. And don't forget to take a photo of the notes that you took in class or in this video today. Share them in Google Classroom so I can give you credit for this assignment. End strong. Show me your homework. All right. Thanks a lot. And I will talk to you later. Stay out of trouble. Goodbye.